Welcome everyone. I'm Mohamed Moussaoui, and today we are diving into NATS, the cloud native challenger to Kafka's messaging throne. Get ready to explore how NATS is shaking up the world of distributed messaging. And to kick things off, let's dive into a real-world scenario that illustrates why efficient messaging systems are crucial in modern applications. So imagine a smart city where various systems communicate seamlessly. We have a weather station that reports high temperatures, triggering notifications to citizens, and meanwhile, smart thermostats adjust to manage power loads. This interconnected scenario is made possible by efficient messaging systems. So in today's world, several messaging systems are widely used to enable such complex and real-time environments. But before talking about that, let's quickly define what is a messaging system. So a messaging system is the backbone of distributed applications, enabling different parts of a system to communicate efficiently. It's what allows our smart city example to function smoothly. In the real world, for example, we have Apache Kafka that is widely used and is popular for its high throughout distributed event streaming platform. We have also RabbitMQ that is known for its reliability and support for multiple messaging protocols, and it's widely used for IoT systems. We have also Apache Pusa that is another contender offering multi-tenancy and geo-replication. These systems have been the backbone of many applications, powering everything from financial transactions to social media feeds. For example, Apache Kafka is developed by LinkedIn for its feeds. So these systems have proven their worth in handling large volumes of data and enabling real-time communication between different parts of a system. However, as we move further into the cloud-native era, new challenges are emerging, and this is where NATS comes into play. Current streaming technologies face several significant challenges. First of all, we have the infrastructure complexity that can quickly become overwhelming, especially as systems scale. Our setting up and maintaining streaming technologies requires a deep understanding of these systems and significant operational effort. Scalability also is another constant challenge as the volume of data and requests grows. Handling extreme scale requires resource optimizations and can lead to substantial resource consumption. And maintaining data consistency and reliability across distributed systems also presents complications. Ensuring message delivery in distributed environments can be difficult, particularly in scenarios involving network failures or node outages. These are the core issues in the messaging systems, and here enter NATS, the messaging system designed to tackle these issues head-on. NATS is a simple, secure, and high-performance open-source messaging system. It's designed for cloud-native applications, designed for IoT messaging and microservice architectures. And also it's designed to go to the edge, from the cloud to the edge. And NATS stands out with its ease of deployment, built-in security features, and ability to handle millions of messages per second. It's built to tackle the challenges we just discussed. NATS sounds promising, doesn't it? But you might be wondering, what specific features does it offer to address the problems we've discussed? So let's dive deeper into NATS capabilities. NATS architecture is divided into two main components. We have NATS Core and NATS Jetstream. The foundation of every functionality in NATS is publish-subscribe model, and it's often referred to as PubSub. So let's start with the NATS Core. At its heart, as I said, we have the PubSub model, where publishers send messages to specific subjects and subscribers receive messages from one or more subjects. These subjects are organized hierarchically like a tree structure, as we see here. The hierarchy is built using dots, and while publishers can only send a message to one specific subject, subscribers have more flexibility. They can subscribe to one or multiple subjects using wildcards or wildcards. We have two types of wildcards. The first one, the asterisk, which matches one token in the hierarchy. And the second one is the greater than symbol, which can match one or more tokens. So building upon the pub sub foundation, NATS also supports a request reply model, rec-rep, enabling more complex communication patterns. And for load balancing, NATS implements built-in queue groups, efficiently distributing messages among subscribers, and we'll see that in the demo. This feature is crucial for our horizontal scaling of microservices. And additionally, NATS clustering provides high availability. It relies in a gossip protocol for server discovery and a raft-based system for leader election. Now, when we enable Jetstream, that is just so easy to enable Jetstream in NATS, we unlock a whole new realm of possibilities. We have Jetstream that provides a built-in processes engine, allowing messages to be stored and replayed later. And this capability enables fault-tolerant and high availability configurations. Also, with Jetstream's streaming functionality, we gain fine-grained control over messages handling. We can configure replay policies, for example, specifying that a consumer should receive stored messages at the original publication rate rather than as fast as possible. We can also set retention policies based on time, message count, or size. And furthermore, Jetstream can be configured as a shared work queue, facilitating task distribution among multiple workers. Also, Jetstream offers a key value store built on top of the streams, which can effectively replace Redis in many scenarios. This key value store allows us to perform operations like storing and retrieving key value pairs, setting expiration times for data, and even executing atomic operations such as compare and swap. Its flexibility makes it ideal for configuration management, distributed locking, or as simple as a cache. Another powerful feature in the object store is the object store in Jetstream. This is particularly useful for handling larger data sets of files within your NAS system. You can store and retrieve large objects, manage their metadata, and implement versioning, and it's especially valuable in scenarios requiring file distribution across your system or when maintaining a history of object changes is necessary. And last thing is security. So security is the priority in NATS. We have features including TLS for encryption, we have in-key for authentication, and GWT for authorizations. So NATS supports multi-tenancy through separate accounts, each with its own subject space and security policies. To address scalability and deployment flexibility, Jetstream is multi-tenant, horizontally scalable, and supports various deployment models. A particularly interesting aspect also of Jetstream is its decoupled flow control. This means producers and consumers can operate independently. If you have a slow consumer, it doesn't impact your producers or other consumers. This feature is invaluable for building resilient systems, allowing scenarios where a consumer can catch up on historical data before transitioning to real-time processing, all without affecting the rest of the system. So in conclusion, the combination of NATS core and Jetstream creates a powerful and flexible system for building distributed applications, whether you are implementing a simple messaging, a complex data streaming, or need persistent storage. NATS provide a comprehensive solution to meet diverse architectural needs. Let's pass to the demo. NATS, it's very easy. You can go to the nats.io website and install it directly with the exe, or you can also install it with Choco or any package manager in your system. For me, I already have NATS. I will show you how to start the server using the NATS CLI command. It's very easy. We have the server built in the NATS CLI. You can easily say NAS server run, and it will start a local development NAS server. We can also specify that we want to activate Jetstream by passing the Jetstream flag, or we can configure our server using Conf42. In the conf file, we can activate the Jetstream, we can add accounts, we can activate WebSocket to connect our web apps directly to NATS, we can activate the endpoint of the WebSocket, and we can, as I said, we can like configure the clustering, the supercluster, we can activate the accounts. But let's keep it simple, and we just start NATS without Jetstream. Today, I will show you just the pub sub and the request reply models, but you can check the website for the documentation and for seeing what we can do with Jetstream. Let's say we stay on the smart city example, and we have, for example, our weather application that is connecting to subscribing to temperature of a city and for a zone, for example. We have now a subscriber waiting for messages in the subject temperature Casablanca zone 1. And we can easily send a message using NATS pub temperature Casablanca zone 1. And we can specify the message. We can send any type of message. We can send G zone, B zone. We can just send Porto or just a simple string. 26, and here the message is received, and we specify in which subject receives the message and also the text. Also, what we can do, we can say, for example, we have another application that is, for example, the thermostat is waiting for temperature in all the zones of Casablanca. We can specify the wildcard asterisk, and it will connect to every zone of the city. So if we send the same message, it will be received by these two subscribers. But imagine we are sending a message to zone 2, for example. It will be received only by the second subscriber because it's saying that I want all the temperatures of the city Casablanca. And also we can, for example, we can subscribe to all the cities and all the zones. For example, we say temperature, and we pass the greater than symbol, and so now it's subscribing to all the cities and all the zones. For example, if I send the same to Rabat, for example, it will be received by this subscriber, not by this one. And if we send the same thing to Casablanca as we tested Casablanca, it will be received by the queue because this one is waiting for all the tokens that comes after the first token temperature. Let's say we have multiple servers that are, or multiple nodes that are waiting for the data from the data of the temperature of all the cities, and we want to load balance the messages. For example, we have a subscriber that is waiting for all the temperatures on all the cities, and we can say, for example, it's part of the queue thermostat, for example. And we have another node waiting for the same thing in the same queue. And a third one. And let's say we are sending a message every second in the Casablanca, and we have the count, and so we are sending a message every 1 second to this subject with the same message. And as we see here, the messages are evenly received by the three subscribers. And imagine we have the third one that is down, and we have the two that are staying up, and they will receive, of course, the rest of the messages. The last thing that I want to show you is the request reply model. For example, let's say that we have a server that is waiting for requests on the reply. Is replying on the subject slogans Palestine, and is always responding with from the river to the sea. And we have another server that is waiting or asking for this message, so we can send request slogans Palestine, and we can say free Palestine. We will receive the message from the replier, and as I said, everything is built on top of the pub sub model. So if we say let's listen to every subject, a sub to every subject, and if we send a request here, the same request, we will see that the request, even if it's a request, it's in the same time pub. We are publishing to subjects, and we receive the response in the inbox. This one is inbox is the inbox of this requester, and it have the same, it's the same ID of the inbox. So that's it for today. You can check the website of nats.io to have more examples of the NATS core and the NATS Jetstream.